Hey guys, here's an update on my sort of Don Smith device that I've been working on and playing with. I've made a couple of changes and changed out the BIFILAR coil or rod to a much smaller one, and it seems to be working a lot better. I've also tuned it a little bit differently. And yeah, I'll show you what I got. So the light, again, it's full brightness. It's I have a cup on top of it because I can't even look at it. It's so bright. It's a 120 volt bulb. I'm not sure what the watts of it is, but it's pretty bright. It's high intensity. I've got the meter, which is pegged, which means it's over 2,000 volts. And the meter is hooked across the light. So it's reading the voltage across the light, which is right here. Where's my finger? There's the positive, there's the negative, both those go out. So the light, it's hard to see, it's a mess. I'll do a drawing and show you what's actually going on here, but I want to show you the rod. Look at how small that thing is. It's a pencil ferrite rod, I think that's what they're called, and it's extremely small. Be careful, just get a shock. Extremely thin. Maybe it's 3/8 or less of an inch. So I've got two signal generators going into one side of this, and the other side is coming out and going through this bridge rectifier, which you can see has a number of capacitors on there, and it also has all of these capacitors on there, and that's just for tuning. And I'm going to say this again, if you haven't tuned one of these things, it takes me a couple hours to tune it. In the process, I end up blowing up diodes and capacitors and MOSFETs. I've gone through so many MOSFETs. So it's really important to get it tuned correctly, and once you do get it tuned correctly, it's amazing. Like, I'll take see if you can just see it. I don't know if this will do it justice, but it's full bright. I can't even look at it. It's probably brighter than it should be. Yeah, so that's it in a nutshell. So I got the power coming out from the battery, going through the PWMs, and both PWMs go into one side of this rod, and then goes into the MOSFET, and then just comes back into the negative, and then shoots out to the battery. There is no transformer on this thing. This thing's making thousands of volts, tons of power. I can't measure the input, but I'm gonna guess, just based on me putting my hand on the rod and the temperature of the MOSFET, which I'm just it's not even warm, but I keep the fan on there because I can't take a chance on blowing it. I've blown so many, it's driving me crazy. So I keep the fan on there just as a precaution, although it's not even lukewarm. So that rod's not even lukewarm, the MOSFET's not even lukewarm. If there's any amperage going through, especially that pencil thin. Where's my pencil? I got a pencil kicking around here somewhere. Especially that pencil thin ferrite rod. Here's a pencil. There you go. Right, it's basically the size of a pencil. Thickness anyways. I believe they are called pencil rods. There's not much going through there, but there's a tremendous amount of energy coming out. It's a bit screechy right now. I'm going to tune it a little bit more just to get rid of that. Bump it up to a higher frequency. And hopefully I'll get my hands on an analog meter or two, because my meters are toast as mentioned, and I can't seem to, regardless, I can't measure it. I've tried hooking this up to see what's going into the light, and the meter just won't read it due to the magnetic flux, I guess. As well as I tried hooking it up to the battery to see what's coming out of it. I can't read that. I've put it across the battery. I can't read that either. The meter just goes nuts. It bounces all around. It doesn't hold anything. This is the only reading that seems to stick, and that is across the light. And sometimes that fluctuates a tiny bit too, but right now it's pegged. Again, the meter's across there. Got some capacitors on there. And again, some capacitors there. They're all used for tuning. And I also have one ground wire going down on the negative side, just into the plug. It does seem to help a little bit. I'm not sure how much. But yeah, it's an interesting effect. If you guys want to replicate it, that would be great. Hopefully you got better meters than me, and you can maybe tell me what's going on while I'm waiting to get some new meters, because I don't have any funding. If you would like to get a plan off of me to replicate this, I'd love to sell you one. It's only 50 bucks. And for those who've already purchased it and are probably watching this, I do appreciate the fact that you've helped me out. And I'm going to send you the updated drawing of the new setup that uses a smaller bifilar rod, and a list of the new capacitors that I've used. I'll just send that to you as an update, no problem, because you've already purchased the plan. And for others, I appreciate it if you kind of, you know, jumped on board and grabbed a plan and put this thing together and started experimenting. I don't want to hoard anything or hide anything. I don't want to be one of those guys that eventually figures it out and dies and nobody understands what's going on. So do yourself a favor, do me a favor, and the world a favor, and just, you know, grab some plans off me and play with this. It's amazing. I wouldn't call it an inverter by any stretch of the imagination, because there is no transformer. There's just that little bifilar rod that I'm showing you. And I've played with these rods. They're specifically wound for this type of project, and they work amazing. So hopefully in the future I can take some better measurements. Again, I just got to get some analog meters, and we'll go from there. But yeah, it's as bright as it can possibly get without blowing. That's it.